And I'm going to look at some problems here that relate to working with time series data and homework number 6. I've already read in some data, or read in a data set here. It's called stock prices. And so let's just take a look at what's there in this stock prices data set and actually get that out and move that from the comment that way. So what I've got in this data set is a date. There's a time trend. It just starts out 1 on the first date, and then the S&P 500, the Dow Jones Industrial Average, and the FTSE. So that's the London Stock Exchange in England. And just so you can see what these are, right? So you can see, well, this time trend, max of 61. So there's 61 time periods here, but let me just show you what these are just to get a little feel for this. Let's use head. And this is in January 2010 and goes out the 60 dates. So January, February, March. So it's January through March of 2010. And then you can see some of the values there for the stock indexes. So first thing to do here, we're just going to regress, let's just say the Dow on a time trend, get that there, or actually let's work with the FTSE for the moment. So let's go ahead and have our model and linear model, and we will say FTSE. Let's regress that on the time trend. Data is the stock prices, and we'll just run that. And we can go ahead and look at the model, and then we'll examine the residuals as well. And so it looks like it's highly statistically significant. So I'm just coming down and looking at this time trend here, and it's got a t-statistic of 4.5. So it's highly statistically significant, right? The p-value is 0.0, well, it's really small, 0.00000294, so very small. R square, not especially large, 0.2579 is on the small side, but not meaningless. So got that there. Well, let's go ahead though and look at the plots, and we'll get this out here. Let's plot M and see what it gives us. And it looks like there's an issue, right? So I can see here on the residuals versus fitted, it looks like something's going on. This does not look linear. Looks like there's something not right. I can see that also here. There appears to be some kind of pattern, right? Something funny going on. So maybe this isn't quite right. I can look at some other things to examine these residuals though here. So let's suppose I want to do something else though. I can say, let's get this out as just one plot here, because maybe I want to plot the residuals based on just straight this time index, plot them against the time index, so I can see better maybe whether or not they're correlated, and they do appear to be correlated, right? So I can see here, let's get this 0 line. So actually maybe we want to put in something that makes it easier to see where the residuals are positive versus negative. So I can do that with AB line. I want a horizontal line at 0. I want to make the color, pick whatever, but let's go with red, make it easy to see, and just put that in there. If the line isn't thick enough, maybe I want to make it thicker, so I do something like LWD for line width and make it a little little thicker, easier to see. But now maybe it becomes apparent that they're correlated, right? Positive residuals tend to be followed by positive residuals. Negative residuals tend to be followed by negative residuals. And I can do that. So I've already here plotted them out. But now maybe let's do the Durbin-Watson test. It's a test for autocorrelation. And so DW test right here, and let's what do we call it, M for our model. And so then let's just run that, and it shows a very small p-value, right? So p-value is 0.0. We got 15 zeros and then 2. So very small, suggests that we reject the null hypothesis of no correlation. And so it appears that they are positively correlated. So that's what's going on there. All right, then let's go ahead and create a lag for this FTSE. So what we're doing here with the lag is saying, what was the value on the day before? So we'll just go with stock prices, and I'll say lag for FTSE 100, make it long just to be silly. And you know, what is this value? Well, I'm actually going to leave the first value. Well, not the first value. I'm going to leave. Yeah, the first value here, I don't have in this data set, right? So if I look at the very first day, so let me try and be less confusing. If I look at the very first day, January 4th, and I'm trying to find what was the FTSE on the day before. Now I can go get that the same way that I went and found this. Go online and find out what it was. But as far as this data set goes, I don't have the FTSE for the previous trading day in my data set. It's missing. So I can't, for January 4th, I'm not going to be able to come up with a lagged FTSE value. So I want to note that up here, right, that I'm not going to have that in there. So I'm going to start with the second row, January 5th, and then I'm going to have that go out through however many rows I've got. I know there happen to be 61. I could see that before, but number of rows for the data set, so stock prices. All right. So now what am I going to put there? What is going to become this lag value here? Well, I'm just taking the values from the stock prices for the variable FTSE. So FTSE there. But what am I putting in this place? I'm taking the value from row 1 and putting it now in row 2, right? So I'm taking the value from row 1. Move this out here. So I'm going to, on the second entry, January 5th, I'm taking the value from January 4th, right? So I'm doing this from January 4th out to, now I don't want n row, but I want n row minus 1. So I'm going to come over here and just minus 1. Get that in there. All right. So let's create this. Let's see if that worked. And now what I want to do though is I want to just take a look at it. And so I'm just going to say head stock prices now, and I'm going to take a look at it. And here, just a comment, because I have had some experiences with students in the past getting upset with. So specifically thinking of an occasion of telling a student to look at the data, and the student complained that they had looked at the data, but clearly they weren't processing what was there. So the student maybe looked at all this stuff down here and said, oh yeah, I looked at it. I saw it. But they weren't looking at what is this telling you? And when I'm saying to look at these, check, are these matching the way you thought they would, right? So is the lagged value for the FTSE, does it match the value on the day before? And so looking at it, just checking, do those match? Do they fit your expectations? Is what we're going with. So if you hear somebody say, look at the data, it doesn't mean just, oh yeah, I see it all there, great. No, wait, you need to have some kind of feel for what the variables are, what they're telling you, or understanding what's going on here. Okay, you get this one is not populated. Again, we could go online and find out what the actual value is. In fact, I went online to get these observations. So okay, so we've done that. We've created this lag value, and now we want to just run a regression using that lagged value instead. So let's just call this one m.l for lagged, and we've got a linear model. We're going to go with FTSE, and we're going to regress it now on, copy paste here, the lag value. And data equals stock prices. I'll go with that. And we've got that going, and we can get a summary if we want. Lag, check that out. And what do we see here? This gives us a much larger R-squared. It explains things much better, right? Again, we have very large t-statistic, so much larger than it was in the previous example. But that's what we've got going on. So now let's, though, again, perform this DW test, Durbin-Watson test. So let me just come copy this out here and see what this looks like. Oh, my mistake, right? So I got an error message. Obviously, I typed something in wrong. Instead of being a 1, that's an L. So just error message, just check it out. What is it telling you? And let's see, it looks like, again, we're going to reject the null hypothesis that the errors are uncorrelated. They're still correlated in this example. Clearly, though, the p-value is dramatically different than it was. If we go back for our previous example, right? This is 0.000000000, you know, 0.000 whatever. Whereas now it's actually close to the 0.05. But we could plot this out too. So let's just maybe go with our getting a plot here. Oh, so check if they're correlated. Yeah, I'm already jumping ahead. So the Durbin-Watson tests suggest that they are, but we could look at the plot of the residuals as well and see what that gives us. And so I look over here now, and it's not quite so clear. It's I don't immediately see the pattern, but the Durbin-Watson statistic is picking that up, right? Certainly not as clear as if we go back and look at it with the time trend. Okay. All right. So now another thing to do is to check out using the Cochrane-Orcutt and or the Prais-Winsten procedures. We could do that with the same regression that we had before, or we could do that with a different setup. Let's go ahead and just change the variables here. So I'm just going to copy this and do something a little different. Let's say our dependent variables is going to be the Dow Jones Industrial Average. So, and let's regress that on the FTSE. So the idea here would be something like the stock market in the UK closes before the stock market closes in New York, right? Because it's further east, if you will. And so it closes first. You would have knowledge of what the closing price or closing stock index was for FTSE 100. FTSE, and you can use that to maybe take some guess about what the closing for the Dow Jones would be, just to be a little bit silly there, but you could do that. So let's run that, and let's just perform a Durbin-Watson test here again. So test, and m.d. So I haven't even looked at the, actually, let's get the summary out. Sorry, getting a little ahead of myself. So just check this. And get a fairly large R square, highly statistically significant, right? Test statistic 23, very small p-value, again, right? Coefficient of 1.315. Right? Well, let's just check, use the Durbin-Watson test to see if the residuals are correlated. And it looks like the p-value is very small, right? So we reject the null hypothesis of no autocorrelation. All right, so what we want to do now, though, is take this same equation, the same model, and now try the Cochrane-Orcutt procedure. So I've got this library, I've already got it in there. So let's do Cochrane-Orcutt, and I'm going to just put in this model, m.d, and let's go ahead and call this m.co for Cochrane-Orcutt, we'll just call it, and run this. And then let's just get the summary out. And it tells us here what we get for the coefficient, 1.29, coefficient on the UK's stock index. So it's just slightly different from what it was before, right? Before it was 1.315, so it's just a little bit smaller. But before, the t statistic was 23, a little over 23, and now the t statistic is 11.32. So we get some changes there in terms of what's going on. Before we had an R square of 0.9, now 0.688. Right. Looking at the Durbin-Watson statistic, before we had a p-value of 0.0000, keep doing that until you get to the 1.26, right? So highly statistically significant. Now we get a p-value of 0.77, right? So in this case, now we're failing to reject the hypothesis of no correlation amongst the errors using the, again, using the Cochrane-Orcutt procedure. So again, I'm not explaining the Cochrane-Orcutt procedure in this video. I'm just showing an example of using this line of code. But go back to the course lectures, consult your textbook to get a better feeling for understanding what's going on with the Cochrane-Orcutt procedure, if that's of interest to you. So then the other procedure that we had is the Prais-Winsten. So I use the Prais there. And then let's go with Prais-Winsten. So here, let me go ahead and maybe type in something wrong just to, yeah, let's just try to get an error message for a moment. So I type in the same thing as I had with the Cochrane-Orcutt, right? So maybe I want model or m.pw, and I try this. Let's just see what happens here. And it comes up with some message, right? Error in the data frame, argument data is missing with no default. And maybe I'm a little confused, right? I just typed in essentially the same thing as I did for the Cochrane-Orcutt, right? Except now I type in Prais-Winsten, and I used MD, and it didn't work. Okay, so how do I work with that? Well, let me just try and see if I can find out what I did wrong. Now, of course, you can go back to the course notes. There's an example in the lecture doing this, so that could be an option too, of course, or searching on the internet would be an option maybe. But I've got this here. Let me just go to the help, and I come over here in the help window, and I try to figure out what's going on, right? So it says I need a formula. I think that's what this is, right? It's a model object. There's a formula in there. It says I need data. I need index. So maybe there's an example down here somewhere. Give this a try. So I've got this example down here, Prais-Winsten, y tilde x, data. Well, let me just maybe try that instead. So let me go with this, and I'm going to get another error message, but let me just copy and paste what I had in there. So now it looks like the y tilde x, and I'm regressing the Dow Jones Industrial Average on the FTSE 100, and I've got the data in there as well. I'm going to get another error message here, so but let's just check this out. Say I run this. Okay, I think that was the change it needed, and it says, oh, error something. Index is missing. Oh, so maybe I want to put this index in here. Now, in our case, we can go with index is equals null, or in this case, you could use, if we go back up here, you could tell it that it is the date in here. So we've got this date variable. So you could tell it stock prices, $date. You could do that, but they're already ordered with the date. So you can just use null. Is there? So let's run that. It looks like it went okay. So let's go see summary and dot Prais-Winsten. And here we get this out. So again, the coefficient on FTSE now is very similar to, I think, the Cochrane-Orcutt, right? 1.29 and 1.292, or almost 1.293. So not identical, but very similar. Similar test statistic, looks like 11.46. With the Cochrane-Orcutt, it was 11.32, so fairly similar. R-square, though, a bit larger, noticeably so. As far as the Durbin-Watson statistic, right now we get 2.226. So again, that's going to be, we check this, but that's going to be not statistically significant, right? So we're not going to reject the null of the errors being uncorrelated in this, with this transformation that's being applied when using the Prais-Winsten procedure. But again, you can look at all this output as needed, but there you go. So that's an example with the Cochrane-Orcutt procedure and the Prais-Winsten procedure. And hopefully that helps just in getting a feel for what's going on with the homework. And hopefully that just, again, sets you up on a good foundation for working through some things there.